Alright, welcome. In this video, we're going to be working AP Pre-Cal Homework 6.2. And so I think it's going to kind of start us off and kind of lead us back through what we discovered in the lesson about radians. And so we're going to start off with the idea of what's the degree equivalent to the radian measurement. And I think what I'm going to do, I'm going to start by drawing a little diagram like that, and then, kind of reminding you of the idea of radian measurement of an angle. So in standard position, our angle is always starting there, and then it's going to rotate counterclockwise if we've got a positive angle, and the amount of measure of the angle, the radian measure, is equivalent to, if this circle has radius 1, the length of the arc subtended by the angle. So for instance, if we were talking about theta is, that much angle right there, the number of radians is going to be the length of this thing. And so 2 pi is, that's the whole circumference of a circle with radius 1. So that's going to be the whole circle, and I would say that's 360 degrees. Okay. Pi is going to be half of that because it's half of 2 pi, so that's 180 degrees. Pi over 2, I'd divide that again. That would be 90 degrees. Okay, pi over 3, okay, well, I'd take that pi and divide it by 3. 180 divided by 3, that's going to be 60 degrees. Pi divided by 4, that's half of pi over 2. Half of 90 is going to be 45 degrees, and pi over 6 is half of pi over 3, so it'd be half of 60 is 30. All right. Write the radian measurement as a sum or difference of pi over 3, pi over 4, pi over 6 with 0 pi and 2 pi. For example, 7 pi over 6 is we get that by, it's a little bit bigger than pi. It's pi plus pi over 6. And this is going to be helpful to when we need to go find these locations on a circle. So 2 pi over 3. So that's 2/3 of pi. That's not quite pi. So that's going to be pi minus something. Pi minus 1/3 of pi. Because pi right there, that's 3 pi over 3. If I had 3 and I lost 1, that would be 2 pi over 3. All right, 11 pi over 6. Okay, we're looking at the 11 over 6. Okay, is that close to 0? Is it close to 1? Or is it close to 2? That's pretty close to 2, because 2 is 12 over 6. So I'm going to say this is going to be 2 pi, which would be 12 pi over 6. And I'd subtract 1 pi over 6. 3 pi over 4, that's 3/4, that's close to 1, so that's going to be 1 pi minus 1/4 of pi. Would give me 3/4. Okay, 5 pi over 3, let's see. I can see this, you can go either way, especially if you're comfortable with the idea of 2 pi over 3. But what I'm going to say is, since it's more than 1.5, it's going to be closer to 2, because 5/3 is 1 and 2/3. So I'm going to say we've got 2 pi, and to put that in thirds, that would be 6 pi thirds. And I would subtract 1 pi over 3. Okay, and then 7 pi over 4, again 7 over 4, that's close to 2, because 2 would be 8 over 4. This would be 2 pi, which would be 8 pi over 4 minus a pi over 4. And 4 pi over 3, 4/3, that's 1 and 1/3, that's kind of close to 1. So I'd say that's 1 pi, which would be 3 pi over 3, plus an extra pi over 3. Then 5 pi over 6, that's almost all the way to pi. That would be 6 pi over 6 is 1 minus a pi over 6. And yeah, I'm glad we did that because I think that'll be useful, not just in this lesson, but pretty much throughout the whole unit, and I guess the whole quarter. All right, now we're going to draw the terminal ray of the radian measurement in standard position. Okay, yeah, and label the angle created with the terminal ray and the x-axis. All right, I think I see what we're saying here. Okay, pi over 6, that's a 30-degree angle. That's pretty close to 0. Okay, so it's going to be in the first quadrant. And so I'm going to say, I'm just going to draw the initial ray here, and the terminal ray up here, and that angle here is 30 degrees. Okay, so always that reference angle, it's going to be one of our special right triangle angles, so either 30 or 45 or 60. Okay, pi over 3. Okay, that's a 60-degree angle, but that's still, you know, less than half of pi, so it's going to be in the first quadrant. Let's say it's up that way, and it's 60 degrees of rotation. That's pi over 3. Okay, pi over 4, that's 45-degree angle. Let's see, about like that, yeah. And I would label that as 45 degrees of rotation. What else we have? Okay, pi over 2, that's 90 degrees. So my initial ray is going to be there. Initial ray always on the positive x-axis. And then the terminal ray will go up here on the positive y-axis. And that will be 90 degrees. Four pi over 3. Okay, now this is one where we're going to kind of go back and think, okay, this one's bigger than pi, or it's outside of the first quadrant. So I'm going to do what we did on the last page and kind of write these in terms of pi or 2 pi or whatever. Okay, so 4/3, that's just a little bit bigger than 1. So that's equal to pi plus a pi over 3. Okay, so initial ray would be here. Like I said, initial ray always there. And then pi is over here. It's 180 degrees of rotation. And so plus another pi over 3 is another 60 degrees. So I'm going to, you know, have gone all the way there and then 60 more degrees. I think it'll probably be about that. Okay, and okay, I did label the angle it made with the x-axis. They were a little easier. So this one, okay, what we're saying with the angle the terminal ray makes with the x-axis, we're talking about this angle here. So that's going to be a 60-degree reference angle. But here we have, you know, that's what we're talking about. That's the pi plus pi over 3's worth of rotation. Pi over 4, okay, if it's over 4, it's going to be a 45-degree situation. Let's start with my initial ray here. Then my terminal ray will be over here because maybe I guess I'll just draw it first and justify it after. Because I don't think we did this one on the previous page. 3 pi over 4, that's equal to pi minus a pi over 4. So I had pi, but then I needed to go back up by pi over 4. And pi over 4 is 45 degrees, so that's where I got there. Okay, so here we've got, that's 3 pi over 4. The reference angle is the angle we're making with the x-axis, and that's going to be a 45-degree angle. Okay, 5 pi over 6. Okay, it's another one in the second quadrant. So we're going to say that's equal to pi minus pi over 6. Okay. Pi is right there. Okay, so we're going to go back up by pi over 6. Okay, that's only 30 degrees, so it's not very far. And my initial ray will be on the positive x-axis, and then the terminal ray will go up, but only by 30 degrees. That doesn't look very good. Okay, so this is 5 pi over 6 worth of rotation. And then the reference angle here, since I went backwards by pi over 6, okay, I went up 30 degrees, so that makes a 30-degree angle. Right, and 11 pi over 6, that's kind of close to 2 pi, okay, because 11 over 6 is close to 12 over 6. So I'm going to say that's equal to 2 pi, which is 12 pi over 6, minus a pi over 6. Right, so here is the initial ray. 2 pi would be all the way back to where we started, right there. But I'm going to go backwards clockwise, pi over 6, 30 degrees. So go down about like that. And, okay, while 11 pi over 6 is a positive number, so that indicates a counterclockwise rotation, we know that because it was 2 pi minus pi over 6, I went backwards by 30 degrees. And it makes a 30-degree angle with the x-axis, so it's a 30-degree reference angle. Keep going. Oh, there's a lot more. Okay, let's Okay, 2 pi over 3, that's pi minus pi over 3. And pi is over here. So I need to go back up by pi over 3, and pi over 3 is 60 degrees. About like that. So I'll say, okay, that's, whoops. That's 2 pi over 3. And then the reference angle will be 60 degrees. Seven pi over 6 and 5 pi over 4. Maybe I can fit those both on screen. Yeah, there we go. 7 pi over 6, that's a little bit bigger than pi, so that's pi plus pi divided by 6. And there I've got my initial ray. Pi is off to the left, 180 degrees of rotation, and then I'll go pi over 6 more, so that's 30 degrees more, about like that. So that's all 7 pi over 6, but I'm not going to clear that out there. So I can label that as a 30-degree reference angle. And 5 pi over 4, that one's also bigger than pi, so 4 pi over 4 would be 1 pi plus 1 pi over 4. So we'll start like the other one. Initial ray, pi is over here. And it's just instead, I'll go, instead of 30 degrees more, I'll go 45 degrees more, because I'm adding pi over 4. And then I'll make this a 45-degree reference angle. Okay, and then pi, well, that's over here at 180 degrees, so that's where we're going to say, hey, initial ray over here, put a little dot there so you can see it's not the same thing. Terminal ray over here, it makes a 0-degree angle with the x-axis, because it is on the x-axis, and so I guess that's what I'd say, 0-degree reference angle. Okay, that's something that we don't really know how to deal with quite yet, and that'll be its own lesson later on. It's 7 pi over 4, that's almost all the way to 2 pi. I feel like we've already done this one, but maybe I was just thinking of when we wrote this as 2 pi minus pi over 4. Okay, initial ray over here. 2 pi would be coming all the way back around. And so I need to go back by pi over 4, so that'll be a 45-degree angle clockwise, and that's going to be a 45-degree reference angle. All right, 0 and 2 pi. Okay, so this is the thing, is that they're at the same spot. Okay, this is my initial ray. Then that's my terminal ray. I just drew it again. And so 0 is no rotation, but 2 pi is one full rotation. So that's the difference, right? They're in the same spot, but they represent different amount of rotation, which, you know, in lots of like actual contexts are two very different things. Okay. 5 pi over 3 and 3 pi over 2. 5 pi over 3, that's pretty close to 2 pi, so that's going to be 2 pi minus a pi over 3. And it's the initial ray. 2 pi would be going all the way back to where we started, so I need to go back clockwise by pi over 3, and that's a 60-degree reference angle. Let's put that there, 60 degrees. And then 3 pi over 2, that's 1.5 pi. Okay, so I am pretty sure I like really intentionally hit 3 pi over 2 in one of the two sections of AP Pre-Cal I've got, and then I've kind of forgot to in the other. So I'm just going to say, hey, this is pi plus pi over 2. So 1 pi is over here, and then pi over 2 was up here, and pi over 2 is a 90-degree angle, so that means that this has got to be 3 pi over 2, because it's 1.5. So let's say here we have an initial ray, a terminal ray down here, and amount of rotation is 3 pi over 2 radians, and the reference angle is 90 degrees. Okay, yeah, that was a lot of sketching, but I think that was, this homework assignment is exactly what y'all need. I really like the way that we're approaching these topics this year, and I think about the last time I taught pre-cal, and I really wish I'd done it this way. I think it would have been a lot better for the students. So we're building it slowly, and there's gonna be some repetition involved, but I really do think it's worth it. Okay, so the picture given shows ray OB creating a 60-degree angle with the x-axis. Okay, I see that. Ray OC creating a 30-degree angle with the x-axis. I see that too. OE is 45 degrees. Okay. Find the radian measurement of the following angles in standard position. Okay, AOB. Okay, that's a 60-degree angle. That's pi over 3 radians. And I think you're supposed to just know that. Okay, AOC is 30 degrees short of pi. So I'm going to say that's pi minus pi over 6, and that's 5 pi over 6. Now, I think that eventually you will probably kind of just memorize the locations of these radian measures on the unit circle, at least for between 0 and 2 pi. But for now, I really don't think you need to expend a whole bunch of energy trying to memorize, because instead you can just think about it in terms of fraction arithmetic. And so it'll build that skill, and you'll be able to, kind of piece your way through these problems. Okay, AOD. Standard position. That's okay. That's just a straight line. That's the whole x-axis. That's 180 degrees. That's going to be pi. AOE is, okay, so in standard position, okay, I think we're assuming positive rotation here, is going to be 180 plus the 45. So that would be pi plus pi over 4. And that's going to be 5 pi over 4. And then AOF in the standard position. Okay, I think it would be totally fine to say that's negative 90 degrees, which would be negative pi over 2 in standard position, but we're talking about positive angles here today, so we're going to think about it that way. AOF, that's 3/4 of the way around the circle. That's going to be 3 pi over 2, because 90 degrees is pi over 2. Okay, the first quadrant is pi over 2, the second quadrant's another pi over 2, that's a total of pi, and then rotate through the third quadrant, and that's going to be a total of 3 pi over 2. Okay. Now, yeah, here's getting to some of the ones that I think are really to the heart of what AP Pre-Cal is going to be like with the trigonometry. It's a lot more circles and triangles. So we're going to find the measurement of the major arc XYZ. I think I'm kind of realizing I'm not sure I know the difference between the major arc and the minor arc. But I think XYZ, I understand that that's the 4 pi over 3's worth of rotation. That Z is on that terminal ray. And so the measurement of the major arc XYZ, trying to figure out, do they mean the length of the arc, or are they talking about the radian? No, I guess you already know the radian's 4 pi over radian measurements 4 pi over 3. Yeah, so the length of the arc XYZ is going to be, okay, and this is where we're going to need to use that formula. Length equals r times theta. Okay, it really is that simple. Reason being is that really it's a proportion, right? We know that the whole circumference of the circle is 2 pi r. Okay, and then we multiply it by some proportion out of the whole circle, but we know that the circle in terms of radians is 2 pi radians. So it's theta over 2 pi, then we cancel these off and we get r theta. Okay, and so the measurement of the major arc x, I'm going to use some color here. X to y to z. Okay, the length of that blue curve is going to be r times theta. The radius of the circle is 6. And then the radian measurement is 4 pi over 3. Okay, so I could look at that as 6 over 1 times 4 pi over 3. That's going to be 2 times 4 pi is going to be 8 pi's worth of circumference. Okay, find the measurement of the minor arc xz. Okay, well, we could just take the whole circumference and subtract 8 pi, but I think that probably wouldn't be as fun. Okay, we could look at the amount of theta that we had still to go. You could also probably think of that as a negative 2 pi over 3 and multiply that out and then just make it a positive number. That's going to be the exact same thing. Yeah, because it's going to be 2 pi over 3 here. So here I have a pi over 6 worth of area, right? Because that'll add 4 pi over 3 plus pi over 6 will give you 3 pi over 2 somehow. Yeah, because it's 9 pi over 6. And then I add another pi over 2 because of that quarter circle there. And I need to go to twelfths. So 2 pi over 12 plus 6 pi over 12 is equal to 8 pi over 12, which is 2 pi over 3. So that's the amount of theta in here. Okay, so length is equal to r theta. Okay, so 6 divided by 3 is again 2, and so I'll have 2 times 2 pi is going to be 4 pi. And, probably would be good to double check and make sure, we know that the circumference of this circle is equal to 2 pi times the radius. And the radius is 6, so that's 2 pi times 6 is going to equal 12 pi, which makes a lot of sense because 8 pi plus the 4 pi is adding up to the whole circle, which is 12 pi. All right, so angle A is in standard position, so I think we could also draw its initial ray here. So A is that much rotation, okay? And the sine of A, I think what we're gonna do is figure out, we're gonna need, we need the length of the radius. And you can see that over on the right side with that 1.3 and 0. Okay, what I'm gonna do, I think I'm going to just show you here. No, I guess I can just go, hold on just a second, make that nice. And then, okay, so now I've got myself a right triangle. And I know that if the coordinates of that top point are 0 0.5 and 1.2, I know that x has gone to the right by 0 0.5 and y has gone up 1.2. So, those side lengths are those things. And then that other red line here, that's also a radius. So that's going to have length 1.3. And this is just a 5, 12, 13 triangle, just, I guess, divided by 10. Okay, and then we're going to use SOHCAHTOA, right? That's our plan always, is that we're going to find the spot on the triangle, find the spot on the circle, draw ourselves a reference triangle, and then use SOHCAHTOA. So sine of A is equal to opposite over hypotenuse, so that's 1.2 over 1.3. It's 12 over 13. Okay, cosine of A is equal to adjacent over hypotenuse, so 0.5 over 1.3, I might call that 5 over 13. Tangent A, that's opposite over adjacent, 1.2 over 0.5, that's going to be 12 over 5. Okay. Secant, that one's friends with cosine. Okay. So I'm just going to take the cosine and flip it because secant is the reciprocal for cosine. Okay. Then for cosecant, I'm going to go and find cosecant because I know that's the reciprocal of sine. I'm going to flip that and get 13 over 12. And then for cotangent, that's the reciprocal of tangent, and you see what I'm saying. I'm just going to flip the fraction, get 5 over 12. Okay. In the xy plane, angle AOB is an angle in standard position with terminal ray OB, which intersects the unit circle at the point with coordinates 0.6 and 0.8. Okay, when it says the unit circle, that's going to mean it's centered at the origin and has radius 1. That was really bad. I'm going to try a second time. I think that's going to have to do. Actually, I'm going to try one more time, because if anything, I want to favor the first quadrant. Yeah, that'll be good. All right, so 0.6 and 0.8. I am done trying to make this diagram totally perfect. I'm just going to say it's over here, okay? And that's the point x equals 0.6 and y equals 0.8. The radius of this thing is 1. So I know that if I drew a triangle here, hypotenuse would be 1. The x-coordinate is 0.6, so that horizontal leg is 0.6, and the y-coordinate is 0.8. Just like that. Okay, so the sine of AOB, I guess maybe I'll go in and draw the rays. Okay. Yeah, so maybe A is some point out here, O is the origin, and B is somewhere along this line. Maybe I'll put it out here. Just kind of away from my diagram. And we're just saying OB intersected the unit circle at 0.6 and 0.8. We're not necessarily saying B is that point. But that'll be good. I've got a triangle that's going to be, plenty to get sine, cosine, tangent, secant, cosecant, and cotangent. All right, so sine, opposite over hypotenuse, 0.8 over 1. That's 0.8. Cosine, adjacent over hypotenuse. We love these ones with a hypotenuse of 1 because, adjacent over hypotenuse is going to be adjacent. Divided by 1, very easy. Tangent is going to be 0.8 over 0.6. That's something we are going to need to simplify. 8 over 6 is 4 over 3. Secant of AOB, that's the reciprocal of cosine. Okay, 1 over 0.6. I don't know about that. I think we might need to convert 0.6 into a fraction. And that's going to be 6 out of 10, which is 3 out of 5. So I'm going to call that 5/3. I'm going to be honest, for AP Pre-Cal, I really don't know if 1 over 0.6 is an appropriate answer in like a free response setting. But I also know that, in a multiple choice setting, I'd be much more likely to give 5/3 as an answer choice than 1 over 0.6. Okay, also, I'm realizing another option for simplifying that fraction. Hold on. Another option was going to be multiply top and bottom by 10. So 10 over 6 equals 5 over 3. And that might be a little more to your liking. I'm not sure. All right, cosecant is the reciprocal of sine, so that's going to be 1 over 0.8. And I'm going to use that same strategy, multiply top and bottom by 10. 10 over 8 is going to equal 5 over 4. Oops. So that's going to be 5/4. And then cotangent is going to be the reciprocal of tangent, so the reciprocal of 4/3 is 3/4. Now we're going to get to doing a little bit of trigonometry. So we're going to draw the special right triangle with radius 1 at the radian measurement. Find the trigonometric function given... Okay. Given pi over 6. I'm not sure. So basically theta equals pi over 6. That's what we're saying here. So we're going to draw our special right triangle. Find it on the circle. Where would it be if we were working on a circle? And so I will draw myself a circle. That one's really bad. I need to figure out some better way to do this. That one was really lucky. Okay, pi over 6 on the circle is 30 degrees. It's not very far. It's the first stop after 0. So I'm going to label it like that. And then I'm going to draw myself a reference triangle. Okay, that's step 2. It said special right triangle with radius 1. That's a reference triangle. So 1, my options are 1, a half, and root 3 over 2. A half is the short leg, and root 3 over 2 is the long leg. And sine of pi over 6 is opposite over hypotenuse, 1/2 divided by 1. Cosine is adjacent divided by hypotenuse, root 3 over 2 divided by 1. Tangent of pi over 6 is opposite over adjacent. So I need to do a little bit of work off to the side. Opposite is 1/2 over adjacent, root 3 over 2. Okay, this is where we're going to need to, looks like I'm going to need to move this. All right, that's going to be equal to, keep the top the same, change the division to multiplication, flip the bottom. to cancel stuff off, get 1 over root 3. We're going to need to rationalize the denominator. And we're going to get root 3 over 3. Okay. Then cosecant, we're going to reciprocate sine, so it's going to be 2 over 1. Secant is going to be 2 over root 3. Okay, that's not simplified radical form, so we're going to multiply root 3 over root 3, and I'll get 2 root 3 over 3. And then cotangent of pi over 6, that's going to be the reciprocal of tangent. Now, I'm not going to go through the whole process of, flipping root 3 over 3 and then trying to rationalize again. That would be silly. Remember that one of the steps we saw that actually tangent of pi over 6 was 1 over root 3. So we're going to flip that, and we'll get root 3 over 1. Much faster than whatever would have happened if we'd done the other thing. Okay, now we're going to draw the special right triangle with radius 1 at pi over 4. So we're interested in theta equals pi over 4, and that's a 45-degree reference angle. It's in the first quadrant, so I'm just going to put it right there. Okay, we don't always need to have the triangle. The circle. We do always need to have the triangle. That was the bad slip there. Okay, we don't always need to have the circle. If we know where the, what the reference angle is, which is going to be 45 degrees here. Okay. Our reference triangle always has hypotenuse 1, 45, 45, 90. Template is 1, root 2 over 2, and root 2 over 2. So, being opposite over hypotenuse, root 2 over 2 over 1. Cosine of pi over 4, that's also going to be root 2 over 2 divided by 1. Tangent of pi over 2, tangent of pi over 4, that's the opposite divided by the adjacent. They're the same, so something divided by itself, that's going to be 1. Okay, as a result, I also know that cotangent is going to be 1, right? Because 1 over 1 is equal to 1. Okay, cosecant of pi over 4, okay, we're going to say, all right, that's 2 over root 2, if you didn't remember that, root 2 over 2 is just the square root of a half. Okay, we would rationalize the denominator if we didn't know what was happening here, and we'd say that's 2 root 2 over 2. Oh, yeah, that's just the square root of 2. And because sine and cosine are equal, that means secant and cosecant will also be equal. And now we're going to do pi over 3, and yeah, that would kind of round out all of the angles that we're going to be doing today. So pi over 3 is up here with a 60-degree reference angle, and I recognize that that is probably quite a bit more than 60. Maybe I'll just put it a little bit off to the side. That's probably more than 60 degrees of angle, but I like to draw the 30-degree and 60-degree reference triangles a little bit exaggerated, so that it's really obvious which leg is short and which one's long. And I bet you've heard me say that at this point, but just want to make sure that, I know that's probably closer to 70 or 80 degrees. Okay, but I'm going to label that as 60. This has 30. That's my special reference triangle. But actually, I'm going to probably take that out because I'm going to label that as pi over 3 radians. So that's really what we're talking about here. Okay, and because it's a 30, 60, 90 triangle, and we're drawing a reference triangle, the hypotenuse is going to be 1, the short side is a half, and the long side is root 3 over 2, long leg at least. Okay, so sine of pi over 3, opposite over hypotenuse. Okay, cosine is a half. Tangent is going to be root 3 over 2, divided by a half is like multiplying by 2, and so that's going to equal the square root of 3. And cosecant, we're going to flip sine, so it'll be 2 over square root of 3. And we've already done this once in this video, but I can do it again. I guess I'm going to do that there. I'm going to say that's 2 square root of 3 divided by 3, because there's nothing more I can do to simplify that. A secant of pi over 3, that's going to be 1 over the cosine, so it'll be 2 over 1. And then cotangent is 1 over the square root of 3, which we would eventually get to root 3 over 3. All right, now, given a radian measurement in standard position, what is the slope of the terminal ray? Okay, of an angle in standard position, I think is what we meant to say. All right, so I'm just going to start with pi over 3. Okay, and give myself an x-axis also. Okay, that'll work. Pi over 3 is going to be, it's a 60-degree reference angle. So what I'm going to do here is I'm going to draw myself a reference triangle. Okay, that's my idea of 60. Get myself third side. All right, so this is theta equals pi over 3. For a reference triangle, the hypotenuse is 1, the short leg is a half, and the longer leg is root 3 over 2. Now the slope of the terminal ray, and pardon me, I thought you could see all that. The slope of the terminal ray is, well, the hypotenuse is the terminal ray, so maybe I'll just extend that a little bit. The slope is rise over run, but this point that I'm labeling here is the point x equals 1/2 and y equals root 3 over 2. This line also, this ray also goes through the origin, which is the point 0, 0. So you could do the, slope formula, y2 minus y1 over x2 minus x1, or you could just look at it as, kind of like how you did in Algebra 1, where it's like rise over run. You even drew these triangles that looked like this sometimes. So it's going to be root 3 over 2 divided by 1/2. But that's familiar. That's also the same as the tangent of pi over 3. And I think I got to the point in one of my classes and in the other where I, showed you how the tangent of an angle is equivalent to the slope of its terminal ray. It's also in the video of the lesson. So that's what we're going to do. And, for this time, I'm going to draw the triangle and, give it a bunch of explanation with the points. But the other ones, I'm just going to draw the triangle and find tangent, right? Because it's just tangent of pi over 3. So for theta equals pi over 3, tangent of pi over 3 is going to equal root 3 over 2 divided by 1/2. Okay, divided by 1/2 is like multiplying by 2. That's equal to the square root of 3. Also, we computed the tangent of pi over 3 like earlier. Right, now we're going to do theta equals pi over 4. So that's a 45-degree reference angle. Okay, like that. That's going to be the terminal ray. So I'm going to come in and draw the rest of my triangle. Probably like this and that. Okay, and so for a 45, 45, 90 triangle, okay, my reference triangle is 1, root 2 over 2, and root 2 over 2. Okay, so for theta equals pi over 4, I'm going to say, okay, tangent of pi over 4, that's going to equal 1. All right, for theta equals pi over 6, that's a 30-degree reference angle, so I'm going to draw my terminal side there, and then I will get a right triangle going here. It's going to be a 30, 60, 90 triangle. And then I'll kind of label the sides, okay, on the reference triangle at least. The hypotenuse is 1, the short leg is a half, and the long leg is root 3 divided by 2. Okay, I'm going to say, all right, well, really I'm looking for tangent, or thinking rise over run is the vertical distance divided by the horizontal distance. So it's 1/2 divided by root 3 over 2. Dividing by root 3 over 2 is like multiplying by 2 over root 3. That's going to be 1 over root 3, which I could rationalize the denominator, multiply by root 3 over root 3, and then I would have 1 over the square root of 3 is root 3 over 3. Okay, and so let's say, okay, over here, tangent of pi over 6 is equal to root 3 over 3. All right, now this last one, inverse tangent of 4 over 7. Okay, inverse tangent does give you an angle measure. Okay, and we'll learn more about that as time goes on. But I'm just going to draw a terminal ray in the first quadrant, and we're going to just hope for the best. Okay, now I am also going to label a point on this terminal ray. I'm just going to put it right there. Okay, then, just like before, I'm going to make my reference triangle. And it'll be great. Okay, now, how do we get inverse tangent, right? We, look at what the tangent is. We already know what the tangent is going to be. So this is theta right here. And so we know that the tangent of theta has to be 4 over 7, because that's what it means for theta to be the inverse tangent. Theta is the angle whose tangent is 4 over 7. So you could look at it like that and say, oh, well, the slope's going to be 4 over 7. But that's the reason I called all these tangent pi over 3, tangent pi over 4, tangent pi over 6, was so that when I got here and I could say tangent of inverse tangent or arctangent of 4/7, remember tangent of inverse tangents undo each other. That's what inverse functions do. So that's going to equal 4 over 7, which you could also see on the diagram. Now I think that's the end of that set of practice problems. So that's going to be all for this video. Thanks for watching.